Hello and welcome to the very first Math AAHL past paper revision over here at Lanterna. My name is Jascha, if you don't know me already. I've been with Lanterna for the last 3.5 years. I took Math AAHL myself, graduated top of class. And yeah, today we're going to be taking a look at calculus questions from paper ones. This is the first of a two-part series. In this first video, we're going to be taking a look at section A questions. In the next video, we'll be taking a look at a section B question. All right, without further ado, let's get right into the question. So I will always up here show you guys where I've gotten the question from. So in this case, it's May 2023, time zone 1, paper 1, section A. I'll also have a little box that tells us what formulas we need. These are all taken from your lovely formula booklet, which I hope you all are very familiar with. If you don't have one printed out laying next to you right now, please do that immediately. You always need to know where everything is. Do yourself a favor there. And yeah, let's take a look at the question. So we have the side lengths x of an equilateral triangle. Okay, quick reminder, what is an equilateral triangle? You should know what that means, just like isosceles and stuff like that. Well, that would be a triangle where all the sides are the same length, right? So we put a little line to indicate that they're all the same length, and those are all the length x. So all those sides are length x centimeters. Okay, it is increasing at a rate of 4 centimeters per second. Now, I think a lot of people are confused as soon as it has anything to do with rates, and it's not just dy dx, but something specific. So in this case, what do we have? Well, we have that dx, so the lengths, right, they are increasing at a rate, so over time, so dx dt, the length x is increasing over time at 4 centimeters per second. Okay, now we need to find the rate when the area of the triangle, find the rate at which the area of the triangle A is increasing when the side lengths are given. Okay, so I have already put this little formula right here. So we know that the area of a triangle has to be a half. A, B, well, since all the sides of this triangle are just x, sides A and B are both just x, so I'll write x squared, sine C, so C would just be any angle in here, but of course, if it's an equilateral triangle, all the angles must be the same as well. They must all be 60 degrees, right? Because the internal angle, total internal angle of a triangle is 180. So if you've got three equal angles, they should be 60 degrees, also known as pi over 3, whatever you prefer. And this is one of those special angles, sine 60. You just need to know these. If you don't know the special angle identities, let me know and write it in the comments, and maybe we'll make a quick video on how you can memorize these very, very quickly. But we can simplify this then as 1/2 x squared root 3 over 2, because sine 60 is root 3 over 2. So that would be root 3 over 4x squared. Okay, so that is an expression of or area in terms of x. And we now need to find the rate at which it is increasing over time. So in other words, we need to find the change in A, dA, over time, dA dt. Okay, well that seems easy enough, I hear you say. It's just root 3 over 4. I put the 2 down from the x. Careful guys, there's a trap here. X is not the variable we are differentiating for anymore. We need to do implicit differentiation, because x is some other variable. We're differentiating for t, right? So we need to do implicit differentiation. Whenever you're doing implicit differentiation, you differentiate the variable that is not directly included in the term down here. You differentiate that like normal, so that would be then 2x. But then you need to multiply with dx dt. In other words, multiplying with the change of x over time. Notice we had that defined up here, so we're going to be using that in just a second. Okay, so we've got that. Well, now we just need to insert what we got. Well, x has been defined as 5 root 3, right? That is the current length at the time we want to see the change. And then dx dt, well, that's just a fixed value. We found that to be 4, right? That was given in the question before. So then we just insert our numbers. 3, well, I guess we can say 3 over 2, so just simplifying these two with each other. Instead of x, we can write 5 root 3. And then we can say times dx dt, that was 4 centimeters per second. And, well, the 4 and the 2, they just cancel out, 3 times 3, so, you know, a little bit of rearranging. I trust you guys can take it from here. This lands us as 30 centimeters squared per second. And just like that, we've gotten the first 5 marks of this paper. Alright, for this next question, we have a continuous random variable, and it has some probability density function defined as such. So this question kind of mixes statistics and calculus. I think everyone's favorite 2 topics. So we need to find EX in terms of A. So just take a second again, try and solve this on your own, see what you get. And yeah, let me just walk you through it here. So what do we have? Well, when X is between A and 3A, it is just a straight line, right? You see 1 over 2A, A is just some constant. So this would just be like a straight flat line. So where would the medium be? So if we imagine it as, I don't know, let's say it looks like this, just purely hypothetically. So this would be A, and then this would be 3A. Well, then we would just have a straight line like this. Where do you think the expected value, the middle, would be? Well, it would literally be right in the middle. And what's right in the middle? That would be 2A. And that's why they just say state EX, because you can just kind of see it like that. So EX is 2A, because it's a flat line like that. Okay, now we need to use integration to find the variance X. So this is where the juicy bit is, and I think this formula right here comes from the most underutilized section of the formula booklet. If you haven't seen this formula before, that means you need to do some practice in this specific topic of statistics, because it definitely does appear every now and then, and I think it takes everyone by surprise, so I thought it'd be a good idea to include in this video. So I'll be using this formula right here, but you can use any other one. There are a few different ones actually you can use here. I think the mark scheme actually uses something else entirely. So I want the integral from, they say minus infinity to positive infinity. Well, all infinities here are just the lower bound and then the upper bound. So from A to 3A, and then x squared. And what is fx? That would be 1 over 2a dx. Okay, that means the integral ends here. And then we say minus the mean squared. Well, the mean expected, same thing. This is the mean, right? So minus, we need to do the bracket here. Be careful of that. Otherwise, you would say 2a squared. This should be 4a squared ultimately. Okay. Now, how do we integrate something like this? Well, this is ultimately just x squared over, and 1 over 2a, that's a constant. We can drag that out in front. So I will say this is 1 over 2a. X squared integrated. Well, how do we integrate? There is a formula, but I trust most of you will probably know how to do this. It'll be 1/3 x cubed. And then I do these square brackets, but you can also do like a long line, whatever you do, completely up to you. And then we'll say upper bound on top, lower bound on bottom, minus 4a squared, don't forget that. That's a typical mistake I would do during the exam, is just to forget this 4a squared. Okay, so then we can just take that 1/3 and we can plop that out in front as well. That's just a constant, right? And then we insert 3a and 1a into our integration, so that would be 1 over 6a. And then we start by inserting 3a, so that will be 27a cubed minus a cubed minus 4a squared. Okay. Then that is 26 divided by 26 divided by 6a, which would of course be a cubed. The a and the a, they cancel out. These both have a common factor of 2. Let's just quickly finish this up. Minus 4a squared. Then we get 13 over 3a squared. Excuse me, that was the ugliest 3 on planet Earth. Let's make that a little bit prettier, guys. That is over 3 minus 4a squared. And if we simplify that to the end, then we just get a squared over 3. There we go. And that is the variance x in terms of a. Fantastic. First 2 exercises done. Let's get to the last one. Alright, let's get to the very last question of today. This question has been taken from a 2022 paper, or the last question of this video anyways. Please stick around for the section B video or click through to that afterwards as well. So again, try and see how you fare on your own here, but we've got some equation, y equals whatever that is, and we've got the tangent of this curve at the point x equal 1 is parallel to the tangent, or the gradient right here, and this is just a straight line, so, you know, dy dx at x equal 1 will be equal to this gradient right here, and we have to find k. So first and foremost, of course, we have a tangent, and the gradient of that tangent makes it so that it's parallel to this line, so of course we need to differentiate. We need to take the dy dx, and we've got two things multiplied, so we need to use the product rule, which is the one I've got right over here. Product rule says first thing not differentiated, first term not differentiated, times the second term differentiated, so e to the power of kx. What is that differentiated? Well, e to the power of kx, e to the power of x stays the same, but we have to multiply with kx differentiated. That's the chain rule in use right there. And then we say plus e to the power of kx not differentiated times 2x minus 1 differentiated, so that just becomes times 2. Okay, now we can insert, so let's say we insert x equal 1, hence we get that, well, 2 times 1 minus 1 times e to the power of k times 1, that's just e to the power of k, plus e to the power of k times 2. And what was this all equal to, guys? This was the gradient. It must be parallel, so it must be, the gradients will be the same, right? So 5, that will be equal to 5 e to the power of k. Okay, quick simplification will hopefully make this fairly obvious. Oh, I forgot my times k right here. Then I get k e to the power of k plus 2 e to the power of k equals 5 e to the power of k, so that I finally can get that if I subtract 2 e to the power of k on both sides, I get that k e to the power of k is 3 e to the power of k, and those just cancel out, and of course finally have that k equals 3. Okay, I'd say these were maybe not the most challenging calculus questions, but if you want a challenge, stick around for the next video, where we'll be tackling a section B question, which I think is going to get quite spicy. So I hope to see you there, guys, and remember, if you guys want any tuition, reach out to us. If you want someone like me helping out with maths, chemistry, whatever, politics, whatever you might be struggling with before the exams, we'd love to help out. Hopefully see you guys in the next video. Take care.